Good morning, everyone. My name is Kevin Lagore, and welcome to the Skywatcher What's Up webcast, where we check out everything that's up in the nighttime sky, to observing and imaging tips, to basically anything we really feel like talking about, because it's our webcast anyway. Welcome. If this is your first time joining us, my name is Kevin Lagore. I'm the product specialist for Skywatcher here in North America. And the What's Up webcast takes place every Friday, 10 a.m. Pacific time. Now that the time has changed, keep that in mind. So we do this every Friday, doing a different topic every week. And at the end of the month, we do a special guest. Now, I'm sure some of you are asking, it's not the end of the month. Well, there's no What's Up webcast next week because it's Thanksgiving and we're closed. So just a reminder, there's no What's Up webcast next week, but we'll be back after the first week of December. Thanks for joining us if this is your first time. If you're joining us again, welcome. And if you've missed it or you want to go back and watch it, all of the What's Up webcast episodes are available at the Skywatcher USA YouTube channel, where you can check out all the previous episodes if there's something you want to see. And then, of course, as with any YouTube channel, if you want to keep an eye on what we're doing or future episodes, you can subscribe to the channel. That'll keep you notified of any new content that's coming up. I know that's a super YouTube kind of thing, but that's how it works. Today we have a really good friend of mine and special guest. His name is Alan Strauss. He is from the University of Arizona's Mount Lemmon Sky Center, and he's going to be on telling us what they do up there, how they do outreach, and all kinds of things that the Sky Center does out there in Tucson, Arizona. So without further ado, I'm going to drag Alan in here, and we will get this going. If you have any questions, just save that to the end. We'll save like the last 10-15 minutes of the hour. We'll save for that. So if you can keep your questions for Alan until then, that'll be great. So without further ado, Alan, welcome onto the webcast. Thanks for spending your morning with us.
Oh, I'm glad to be here.
So I always start the webcasts off pretty much the same way with everybody. Is how did you get started in this crazy hobby of astronomy? Because we all have a story.
Oh, yeah, for sure. Growing up, I live in Tucson, Arizona. I guess I should mention that. I work at the University of Arizona, and I grew up here. And when I was very young, I was very, very close with my grandparents. And my grandfather had a very close friend whose name was Dr. Leon Blitzer. And Dr. Blitzer, I knew him as Leon, was a professor of physics at the University of Arizona. And what I didn't know at the time is that he was world famous, world renowned, and was the leading expert on solar system dynamics. And in the, I think, early 1950s, he became the youngest person to ever achieve the rank of full professor at the university. And he started the PhD programs in physics, and just an amazing guy and a good friend of my grandfather. And so when I was a little tyke in the early 70s, he would come over for dinner and things and bring me these really cool NASA lithographs of Jupiter and things that the Voyager probes were imaging. And as you can imagine, they look nothing like the nebula behind me right now. And so it sparked my interest. And then at some point, probably a birthday, my parents bought me a small telescope. And I laughed thinking back on that, because we would haul this thing up a rickety ladder to the roof, having waited till full moon, right? When the only thing you can really see in the sky is the full moon. Very few details, didn't know how to align the finder. We'd spend, hours keeping this telescope pointed at the moon. And every time a car would drive by, we'd be covering our eyes, thinking that we were protecting our night vision from this bright thing. So, it's come a long way. But growing up in Tucson, it was really the epicenter of astronomy in the 70s and 80s. At least we like to think so. Kitt Peak is very nearby, and university. And so just lots of opportunities to interact with other amateur astronomers in the university. It was just kind of a natural fit and growth into the hobby.
Nice. Yeah, I know we've observed a lot, and I've seen over the years we've spent a lot of time out under the sky, whether it's outreach events or just viewing. So it's always cool to see everyone's story of how they got to interested in this hobby. So at that point, it's cool. You're interested. You got telescope. At what point though because obviously now you're the director of Sky Center, a full observatory complex. So at what point does because I know you've been into it obviously for a long time, but at what point does that shift from amateur hour to where you finally step into pro level?
Yeah, so life's a journey, and I still consider myself an amateur astronomer, not just at heart, but in practice. I still go out, as you know, and I've seen you in places, right? And with my personal telescope. And my educational background is in education. I got my 2 degrees from the College of Education at the University of Arizona, and was working at the university for a long time. And then when they started the Lemmon Sky Center around 2008, 2009, I started volunteering up there, leading astronomical outreach programs for the very fledgling program, and then was quickly hired because they went from a staff of 1 to a staff of 1 and a guy helping the 1. And as those programs grew, within about 2 years, there was an opening. They needed an administrator. And so after 17 years in one job at the university, I managed to leverage my administrative experience with my passion for amateur astronomy and get the job. And I think everybody took a risk, myself making a career change, the department head of astronomy, bringing in a guy that had no formal training in astronomy. I've never taken an astronomy class, and it's been great. I mean, it's been a solid decade of good times and really seeing some amazing changes in the world of outreach.
So I guess I should have asked this first, but because I'm so familiar with it, but others might not be. Can you tell people what the Lemmon Sky Center actually is? I know it's a big thing in Tucson, but
Right. So the Department of Astronomy, of course, has a very long history in astronomy at the University of Arizona. It was started in the very early 1900s by A.E. Douglas, and it was not until around 2007 that the Department of Astronomy really started focusing in on a kind of a nightly astronomical outreach program. So the Sky Center was founded by my colleague, Adam Block, who had this vision for what the university could do. And the kind of heart and soul of it are these public observing programs. So it's a 5-hour program in advance. Unfortunately, COVID has, of course, stopped that for now. But people come up and we spend a couple hours during the daytime orienting them to the site, to the telescope, showing them some things that they can only see in the daytime, right? The sun, sometimes a bright star, maybe Venus or Mercury, just get them comfortable. We have a nice dinner and a lecture, we watch sunset, and then we spend a couple hours at the telescope after dark, seeing things like this nebula behind me. Of course, not in vivid color like that. And the telescopes that we use, we have 2 telescopes. One is a 0.8 meter, 32-inch, the Shulman telescope, and then a 0.6 meter, 24-inch Phillips telescope. And, the programs are really, they're for all ages. We get kids down as young as about 7 who have never done anything like this to retired PhD astronomers in their 70s. And the program meets all of their needs and expectations. It's a lot of fun. I think that primarily what we try to do is help people appreciate at the end of the day that science matters. That's what we're after. And that if we can take all of the wonder and excitement that they have when they show up and help them understand just a little bit about what they're seeing in the telescope, that they go home with such an increased sense of wonder and excitement and amazement. And for many people, it's the first step. I'm sure Skywatcher has seen, lots of sales increase during COVID times, right? People are getting back into understanding what's going on above them. And I think that, sorry, I could talk about this all day, right? Is that
we've got times.
That's right. One of the things that's so great about, astronomy outreach and about our program is that, we bring these concepts home. People don't have to understand much about physics or black holes or radio waves or any of these concepts, right? There are things that everybody can grasp and they go home with a sense of, hey, this stuff's not out of my reach. I think astronomy has too often been perceived as something, very mysterious, only for the most highly intelligent of people. And I think what we show people is that, you can understand this, right? And your understanding can be at whatever level you're willing to delve into this. So it's been very rewarding for me. It's been a lot of fun. I threw this picture of the Triford Nebula up behind me. This was a picture that Adam Block, my colleague, astrophotographer, created. One, because it's a really cool background, but as an example of the various types of outreach we do. It's not just that we deliver these in-person experiences, right? We generate a lot of very beautiful pictures of things up there. And these pictures, we show them in person, they go out on the internet through social media, and they generate so many questions. Looking at a picture like this, people ask, well, why is this side blue? And why is this other side pink? And what about the dark things going through there? And, it looks kind of like a cloud. Is it going to look like this next year when I come back up to the Sky Center? So there's so many things that people make, right? And those observations that lead to their questions, that's the scientific process, right? And we ask them what ideas they have, what hypotheses about why this. And so people begin to see themselves as being capable of understanding the science, and it's really exciting. Right? The only thing that most people will remember from this nebula is, wow, there are stars being born there, right? But that's pretty cool. That one little thing to go home and say you've seen that.
Yeah, I know you guys have always done a really nice job up there, and the programs actually, within just the last couple of years, I feel like you guys have really advanced that a lot. It seems like you've got more volunteers and more staff, and it's growing pretty obviously this year's kind of an odd year, but it's growing pretty exponentially from what I've seen. Is whenever we're out doing events in Tucson, like, guys are known for what you do up there. So
yeah, well, I appreciate your enthusiasm. Exponentially, maybe a lot, but it has grown, right? It's I guess in stellar timelines we're moving pretty fast, but so it's, we can only serve so many people. We try to keep the experiences intimate. So maybe 35 people a night come up, but we definitely are doing a lot of local outreach things, from schools to star parties to science fairs. But the other big thing we do up there, well, there are several, but we do workshops. So people come up and they can spend the night, and we do things on astrophotography, wide field astrophotography of the Milky Way, astrophotography through the telescopes. And it's 101 type workshops. If you've never used your camera, come on up and we'll show you where the menu is in the camera, and we'll get you going on that front. Two very experienced folks that want to come up and take advantage of the equipment. We would call these things outreach, but we also have formal K-12, kindergarten through 12th grade education programs that we call the U of A Sky School. And so that is not just astronomy, but all of the natural sciences that we have access to on the mountain. So it's been a lot of fun to watch it grow and to really become a neat, very unique place for this kind of outreach.
Because I know the Sky Center, for those who don't know, the Sky Center is tightly woven into the Park Service that actually oversees the mountain itself and protects a lot of the environment up there. So you guys, at events I've seen, not just the astronomical side, but I've seen other parts of the education team that are actually promoting the actual nature of what lives on the mountain too.
Yeah, that's right. I mean, we sit obviously in the cat's perch of the Santa Catalina Mountains, which is it's managed by the U.S. Forest Service. And so we operate the observatory under a special use permit. But it's been there since the observatory's been there since about 1970. And originally it was a Cold War military installation. They say it was the free world's highest altitude radar site. And it was part of a national network for air defense. And so as the early 70s came, the university began to work with the military and with the Forest Service to start to repurpose the site for astronomical research. And so much of the original buildings have disappeared, many of them, but there are still a few. There's still one original radar tower. There's no instrument in it. The enlisted men's barracks are still there. The gymnasium is still there. So I can shoot baskets at 9,170 feet.
There's a workout.
Exactly.
So now that the Sky Center's up there, you guys are doing your stuff. I know there's other telescopes on the peak up there, but those are part of. I think what's interesting up there is you have the Sky Center, which has your 32 and 24 telescopes, but it's kind of woven into basically there isn't an actual research observatories that are up there as well, and it's all woven into one facility, really.
Right. Yeah, and that's the only way that this would really work for us, right? Because astronomy outreach is in the best of times a tough business, and it's hard to support that. But we're very fortunate to have support from the University of Arizona, and part of that reason it works is because we do sit in the middle of several research telescopes, and it's those telescopes, at the end of the day, which keep the site operating, right? And we wouldn't have an observatory like we have without those research telescopes. And so, not everybody would agree with this statement, but the flagship project is called the Catalina Sky Survey. Catalina is the mountain range, the Santa Catalina Mountains, and they're a survey program funded by NASA, and they look for NEOs, near-Earth objects, and specifically they're looking for asteroids, and those asteroids which we call hazardous, right? The near-Earth ones. And it doesn't mean that they're near-Earth now, but it means that their orbit might take them inside of the Earth's orbit. And so potentially there could be a future impact risk. And they are the leading program in the world for discovering asteroids. They operate 2 telescopes on our peak, a 1.5 meter, a 60-inch, and then a 40-inch, a 1 meter telescope. And they operate one telescope full-time on the peak just next to us, a 30-inch Schmidt. And then they also utilize the other 1.5 meter telescope on Mount Lemmon, in the Catalina Mountains, which is on the peak. So sometimes they have 4 telescopes operating up there, but always 3. And they have an amazing camera. It's 10K by 10K, and it sees 5 square degrees of sky. So that's 10 times the full moon right there. And they detect literally thousands of objects every single night. Most of those asteroids are known, but on a good night, there are a couple dozen that are new discoveries or more. I should check my facts. And then, 2 to 3 of those are near-Earth asteroids. So there's nothing that we know of right now, right, that's a potential impactor. One of the more exciting discoveries recently, and I should have checked the date, but definitely within the last year, was what hit the popular media as Earth's mini moon. You probably remember that. So that was a small asteroid that was discovered up there and that was in the same orbit as the Earth. So they're a lot of fun, and it's great to have them up there because when the public comes up, they get to learn about that, they get to see it in operation, and people feel like they're coming and getting an experience that puts them in touch with cutting edge research. Right? Doesn't happen often. In fact, it's only happened 3 times in all of human history up there that they discovered an asteroid, very small asteroid, that then later impacted the Earth. And all 3 of the times this has happened in our history, that discovery has happened at Mount Lemmon through the Catalina Sky Survey. So, it's like winning the outreach lottery, right? Imagine being able to go home and say, I was at Mount Lemmon the night they discovered that asteroid that just landed in the ocean.
No, I know it's really cool up there. And I really like that your facility blends it that way because, I know if you step to the other facilities around the country, they've got massive telescopes and they've got their little outreach section in there. But everything up there is there's not a lot of room on the mountaintop. So everything's kind of on each other. So,
right. There's intention to that though as well. And it is exactly what you're talking about there. We could move the outreach telescopes. It's a 25-acre site. And as we think about the future and plans, we've talked about that. Should we move them lower on the mountain? But what we often come back to is no, it's really important to bring the public into this research environment, right? These things are funded by NASA, by the National Science Foundation. And in a sense, we all own this, right? It's all information. And it helps for us to also dispel these ideas that this is a bunch of really smart people playing with really expensive toys, studying some very esoteric thing, right? When they can come up and they can learn about asteroids and understand that, we not only, right, could one of these potentially hit us and we'd like to know about it in advance, but also this is maybe how life came to Earth in the past, right? It's not just some esoteric thing. We're trying to find answers to bigger questions. Where did life come from? How did life get to Earth? Is there a relationship, or I should say, what is the relationship between our star, the sun, and climate on Earth, right? If can we predict the behavior of the sun and maybe, get some warning for future solar storms? So there's lots of big questions that relate very directly to our life on Earth. And the more understanding we have about those things, perhaps we can improve our station here.
Yeah, that's what I like about astronomy, is it definitely brings, a lot of people just overshadow it, where it's like, we're gonna go stargazing, and
That's right.
it's so much more than that.
And I love, sorry,
Oh, go
get me
ahead.
all excited.
Yeah.
I love when people come up and they start talking to the people that are working there, and not just working at the Sky Center, but working at some of the other telescopes, not just Catalina Sky Survey, but we have University of Florida operates a telescope, Louisville University. We have telescopes from the National Observatory of South Korea, for example. So when our guests just start chatting up some of the other staff up there, they're talking to people who have degrees in biology, and people that have degrees in geosciences, and people that have degrees in planetary sciences, and people like me that have degrees in education, and all kinds of fields. And I think that that's really important, because what they see, is a little bit of themselves up there, right? And the connections that happen, that's why I work there, right? You go home at the end of the day and you feel like, well, A, this is a great job, but B, someone had a really good experience today, and that's going to pay itself forward.
That's something that I think is important for a lot of people, because you and I doing a lot of outreach, you get a lot of questions where it's like, well, how do I become an astronomer? And that's such a, I don't want to say loaded term, but it's such a broad answer, because a lot of people just think, oh, you're an astronomer if you do this. Well, there's so many aspects of making telescopes and these observations work that, but you start to find out that you don't have to go to school and you just learn this and poof, you're an astronomer. It's like you said, there's people from all different backgrounds that make these things happen.
Right. Yeah. I mean, they've all gone to school, but it's, what it is it's really that amateur, right? From the Latin about loving something, that drives a lot of the people that are up there. Our outreach staff, I love to use the term they moonlight, because these programs are at night. They're not, we've got a staff of 12 people. They all have other daytime jobs, but they're all up there after working a full day because they love it.
Mm-hmm.
They're all amateur astronomers at heart. Now, some of them are engineers, right? One of them is a laser engineer. One is an engineer for adaptive optics at the Large Binocular Telescope Observatory. We've had staff that do image processing for the Mars HiRISE mission, and we've had people that are college students that don't even have a major yet that are presenting, but they all have this love for astronomy, for learning, and for sharing, and for getting people excited about that. And that's really, I think, what makes our programs excel. It's not that we want to get up there and talk about the equipment.
The equipment's the last thing.
That's right.
That comes up, but it's not. I find when you go out to an outreach event, the equipment comes up, but it's just the tool in the toolbox to make it work. So.
That's right. We explain how a telescope works, and we certainly get the person like myself, like you, who, if we were attendees, we'd want to know all the details of how the equipment is operating and this and that. But what we really get excited about is pushing people to think about what they're doing, to have fun. And I love, when I do a program, I love to get the telescope on an object, have a person come up to the eyepiece, and of course the first thing they say is, oh, what am I looking at? What is it? And I don't tell them. I say, well, why don't you describe what you're seeing, right? And then, I get the next person also to describe, and I get them to make the observations and talk to each other about what they're doing. And what it does is it puts them in charge of that process, right? It takes me out of the role of expert and lets them come up with questions, investigate things, and I'm just there to facilitate that, right, and to help them come to the right answer, and, or at least what we believe is the right answer, right? Astronomy is one of those great sciences where we seem to learn more and more every week.
It lets them kind of discover it for themselves, which I think is what makes it exciting, because we obviously know the majority of what we're showing in the telescope has been known for years. It's nothing new, but for someone to discover it for themselves, it really opens that window that we all love and adore. But yeah, it's to let them kind of take the reins for themselves and not just be like, here's what you're doing, blah blah blah.
Right.
Yeah.
And there's a hierarchical progression to it during the night, which is really helpful. You start off looking at a star. You don't just drop a very faint fuzzy galaxy in the eyepiece, right? You start with a star, and then maybe you go to a cluster of stars, maybe a bright nebula where stars are being born, and you slowly work your way through these objects, right? And then by the time you're showing something a little more unique, the guests have experience, right? They have the experience of observing, so they know how to look through the eyepiece. Maybe they have already figured it out, or we've talked about averted vision, so they have some little techniques to improve their ability to see. They're building those skills up, and then they have the understanding already of different things they've seen in the eyepiece, from color to shape to brightness, and they can describe those things. And then by the time you get to a galaxy, most people can see the galaxy. A lot of them can see features in the galaxy, and they can describe those and get excited about them and talk to each other about them.
That's kind of a cool process, because I think a lot of people who do outreach don't think about it that way. It's just, I have a line of people or whatever, just come look, blah blah blah, onto the next telescope. And I understand that at certain events that's just kind of the process. Yeah. But when you've got stuff like this, you are literally training, I guess, or telling them how to properly observe something. So by the end of the night, you could take someone who's never touched a telescope, and by the end of the night, they're actually well versed in, basic observation skills.
Right. And I think too, one of the things we often talk about in our presentations that was started by Adam at the very beginning was the size and scale of the solar system in the galaxy. And so, those are big concepts, right? And so you work to create a model that people can get their arms and minds around. But we do that early. But then when we go back up to the telescope after dinner, when it's dark, right, then when people start asking you, how far away is this? They have some sense of that, right? You show them a star in the daytime, and they say, how far is that? And you say 10 light years. That's a little bit meaningless at that point. But later on in the night, as they've built up this knowledge through their own inquiry, that means something to them, right? That vast distance, still inconceivable, but they have a frame of reference for it. And I love at the, towards the end, if we show a galaxy and someone says, well, how far away is this galaxy? And it's like, well, this galaxy is, 100 million light years away. And then there's this, pause for a few minutes. And then that same person says, wait a minute. So if that galaxy is 100 million light years away, do we know it still exists? That question comes up a lot. And it's a great question, because what it shows you is, they've been processing and thinking about this stuff, and they've put all of this together, and they realize that, wow, it takes a long time, 100 million years for that light to get here. So how do we know? And of course, we talk about that, right? But to answer their question, we bring it right back to what they already know. And then they realize, hey, I actually knew the answer to this. And the short version is, if a typical star lives 12 billion years or something, right? 100 million years is a very small percentage of the lifetime of even a single star. So you take a galaxy of, hundreds of billions of stars, right? That galaxy is most certainly still there, right? So, but to see the expression on their face and their confidence and satisfaction as they figure these things out is absolutely the most rewarding thing I've ever done.
It's kind of cool. You kind of give them like a puzzle, and throughout the program, the pieces start to be put into place until the end. They finally got a better thought
Right.
on the grand picture of it.
Yeah, that's a great analogy, and it's almost like whatever that picture is on the puzzle, they're kind of determining, right? They're picking out as they go what those takeaways are. Again, our takeaway is we want them to go home and think, wow, science is cool and it matters. It helps us understand the world around us, and that's our little attempt to brainwash everybody. We're not sitting up there, lecturing on this like science matters and you're gonna remember it. Right? No, we help them through a process, and they have fun, and that's the key thing. Is it's a lot of fun.
I think that's the hard part, especially in this day and age with just science in general, that we're seeing right now is a lot of people are unfortunately detached from science. And it's probably, I don't know what the reason behind a lot of it is, but I guess certain people don't like that. They feel like they might be being talked down to, or someone's smarter than they are, and they don't like that feeling. But if you can approach it in the right way and kind of like you guys do, put them in the driver's seat essentially, and be like, look, this isn't something that's unobtainable. Like, you could just as easily, it's not a difficult process to understand. It just takes a little bit of effort and you don't have to take it all in at once. I think a lot of people assume with science it's like I got to take all this fact in one gulp, and it doesn't make any sense that way, where you kind of have to approach it how you guys do, where it's just, start with the basics and then move up to the advanced stuff, and then you've kind of come to the realization that, oh well, that wasn't that hard, and now I can kind of grasp this much larger concept.
Right. Yeah.
Oh,
I'm sure we could go, and there's probably been a ton of research on that, and how we've gotten to this point. But certainly my opinion is that the availability of information, right, electronically has been a double-edged sword. It's wonderful, but we always joke up there, about people, well, I saw it on the internet, right? And so the assumption is it's true.
yeah.
Well, that's harmful. And people, I mean, we all do it, right? We pull a device out of our pocket to get an answer to something. And in some cases, we've lost the appreciation for figuring the answer out. And it's tough. It's definitely our culture has changed, and we just have to be smart consumers of information, but not sell ourselves short, right? There's a healthy balance to being skeptical and being, cynical, but these things are achievable. And if we can help people be curious and tap into that curiosity and see that, there's no inherent conflict between being amazed and wonder, stuff is wondrous, with the fact that, it's pretty orderly, right?
Mm-hmm.
There's some scientific reasoning behind it. And it's through that orderly process that we're going to understand why this nebula is pink, right? Or why this one's blue, right? What's creating those dark lanes, right? We're not just making it up. We had a theory, we tested those theories, and as we continue to collect data, it continues to support those ideas.
Mm-hmm.
All the results that come in are pretty consistent that this is an area that's giving birth to stars.
Yeah, I think it's just important for people to explore science to whatever realm they're comfortable within. But I feel like astronomy is one of the easily most obtainable sciences where you can actually go high up into the research levels. Like what you got, like it's hard to do like an outreach event at for chemistry per se, where it's like, okay, we're going to take you and we're going to throw you into this lab, and that's not as big of a thing. Where astronomy, it's you can go out in your backyard and you can explore astronomy and start that interest.
And it's so exciting. I think that it's, when I do the programs, I guarantee, right, if you do any kind of outreach and you're listening to this, before you go to the outreach event, just get on the internet and look up what's happening in astronomy today, because there are so many exciting things every day, whether it's a new discovery, whether it's a milestone in a mission, whether it's something happening on the space station, whether it's a Galileo's birthday, right? There's so much that people can get excited about and tap into. Kevin, you and I are not that old, right? But I mean, just in our lifetimes, we've gone from grainy black and white pictures of Mars taken by, space-based missions to amateur astronomers, right, in their backyard using equipment that's not that expensive, taking much, much better color pictures, right? I've been seeing, I'm sure many of you have, pictures of volcanoes on Mars that amateurs are taking over the last month. That didn't happen. Just the technology advances have been incredible. If you think back, I don't know, I'll probably get my timeline wrong, but 4 years ago, 5 years ago, one of the big things in looking, for the possibility of life was finding water, right? Can we find water on a moon of Saturn, or can we find water on our moon? And now just about everywhere in the solar system they look, they're finding water, right? Just because our understanding has improved and our ability to create better technologies has improved. And I often remind people that just 100 years ago, right, there are people alive today who were here in a time when we didn't know that fuzzy Andromeda thing in the sky was another galaxy, right? We called it a spiral nebula, and Hubble in the early 1900s, I think around 1919 or 1920, I should look, figured out conclusively that it was another galaxy. So it's only been 100 years to where we've known that it's not everything is just right here with us. And it's, I always tell youth, right? This is the golden age of astronomy. It hasn't passed us by.
We're just getting, you look at some of the telescopes that are getting ready to launch, and we're just getting into basically the second generation of space-based serious space-based telescopes. So we're just scratching the and the equipment now that you can get, not touting Skywatch or anything, but the equipment you can get on the amateur market. I mean, you could do spectroscopy observations of a black hole or a quasar from your backyard with, an 8-inch telescope and a $100 spectrograph. It's, crazy with the stuff that you can actually do now with bare minimum equipment.
Yeah, and it's useful, right? Because astronomy research at the highest levels is very, very expensive. Right? Time on telescopes is hard to come by, but we don't need the biggest telescopes all the time. So if amateurs can harness their collective power, and we can put, multiple telescopes, 6-inch telescopes, 10-inch telescopes, 20-inch telescopes around the world to taking information, data on objects, that's really helpful to professional astronomers.
I don't think a lot of people realize that. Maybe some of you watching might not understand that either. When you're a professional astronomer, you have to apply for time on large telescopes, and obviously there's only so many telescopes available, and there's only so much time, and usually the wait time on these multimeter telescopes are years in advance, and you basically have to book time and hope you've got good seeing for probably that window that you've got the telescope available. And usually that window, Alan, you'd know better than I do, that window's not very big. I mean, you're talking a couple days to a few weeks depending on the project availability. So the cool thing about amateurs is you have a telescope to your disposal 100% of the time. A professional does not have observing time of that caliber on those instruments. So the nice thing, there's plenty of people who are discovering asteroids and comets and supernovas and doing spectral observations all from their backyard equipment because they have way more observing time on their equipment than a professional does.
Right. I mean, even, thinking about asteroids, if we did detect an asteroid that was inbound towards the Earth, and it's happened 3 times, right, the word goes out very quickly on a public website. Regardless, every asteroid is reported through the Minor Planet Center. And imagine if, quickly we could get 100 amateur astronomers around the world to put their telescopes on that. And the only thing we would need is to know the position of that object at that and the moment that they took their picture. Because if, we get a series of observations at Catalina Sky Survey across the sky, maybe 4, right? We draw a line between those 4 to try to figure out the orbit. Of course, I'm simplifying this, right? And, that orbit is curving. So the more points we can put out there of positions, we can get much more precise with drawing that line and figuring out the orbit, right? Is it going to hit the Earth or is it not? And sometimes, we might only have hours to figure that out. Now, You say, well, if an asteroid's coming in and we only have hours, does it really matter? It does, because most of the time, right? In fact, everything in human history, they're not big asteroids, they're small ones. And I'm sure many people remember the one in 2014 or 2012 in Russia.
Chelyabinsk. Yeah.
Yeah, Chelyabinsk, that exploded, and every dash cam in that part of the country got video of it. There were thousands of injuries from glass because the shock wave, when that small asteroid exploded in the atmosphere, and the shock wave, think about a bomb going off, blew out many, many windows and injured many people who were out there looking to see what the bright light in the sky was. Imagine if we could tell you, hey, this is going to happen, don't go to your window, right? The shock wave's not a big deal. It might blow your windows out, but just stay out of the way, right? We could give warning of those kinds of things. And the more observations we have of an object like that, the more precise we can be about the point in time when it would come into the Earth's atmosphere. And there's a lot of this stuff out there, and some of it makes the news and some doesn't. One of the other surveys, Atlas, which has telescopes in Hawaii, I believe, they discovered an asteroid last week or the week before. It had already passed the Earth. And I hope I'm not spilling any beans on this or freaking anybody out. So it was moving away from us already, but when they backed up the orbit, kind of tracked it out, it passed 400 kilometers from the Earth. So that is actually the closest asteroid on record as far as discovery. It was already by us because it was coming from the direction of the sun. But so again, it was a small asteroid, size of like a half-size school bus or something, but still, it's exciting, right?
Yeah. So that's, doing observations like that and what that happens up on those facilities where you guys are at is kind of important. So
right.
With all that
the amateur contribution is equally important, right? Mm-hmm. We don't have enough telescopes to keep track of this stuff.
Yeah, and I know basic equipment, like you got an 8-inch telescope and a decent little camera, which so many people do nowadays. I know everyone's after the pretty pictures and trying to get your APOD stuff, which is awesome. But you'd be amazed how much like critical data that you could be providing for actual projects and be involved in projects with that basic equipment.
That's right. Light is just numbers, right? We convert it to numbers and do the analysis, and it doesn't take a big telescope to see a lot of the objects, especially the close ones. Mm-hmm. And keep in mind, right, that if you're an amateur, the camera is so much more sensitive than your eye. Obviously, the nebula behind me again, right? It's in color. You can see that in an amateur telescope, but it's grayscale. Mm-hmm. Eyes are just not that well. They're not that good at seeing low light objects, especially color ones.
Yeah. So with all that talk on the facility, I know we've only got a little bit of time left, but where do you see Mount Lemmon and the Sky Center going, after the COVID era, and what's the future of the Sky Center?
Yeah, so I think that, short term, it's going to take a little while because people aren't traveling, and we're hoping that a vaccine will widely be adopted and people will go get vaccinated. But until those things happen, a lot of what we're working on is remote observation. So the telescopes right now, I should have mentioned this earlier, they're available for amateurs, citizen scientists, some professionals around the world can purchase time and do that. So we have amateurs all over the world that use our telescopes remotely. They log in from their home computer. Some of them they're halfway around the world, so it's daytime when it's night here. And they take data to make pretty pictures, like the one behind me. Other ones are looking for comets or taking light curves on asteroids or things like that. So as we get better with that, and this is the perfect opportunity, I think that will increasingly be a part of what the Sky Center does, is make these telescopes available to people interested in astrophotography, citizen science around the world. We've always hoped to do it, but this has really kind of spurred us and helped us get off in that direction. I think at the end of the day, we do want to get back to that in-person thing, though. So, I think the future will hopefully look very much like where we were right before COVID, because there is something to that in-person experience, to being hands-on with a telescope, to turning the focus knob, to seeing Saturn for the first time. Right? And for many people, we get a lot of tourists. I'm luckier than most living in Tucson, Arizona, where we have reasonable lighting codes. And I live right at the base of the mountain. I can go outside on a moonless night in the right time of year, and I can faintly see the Milky Way over my house. But something like 70 or 75% of the US population can't see the Milky Way anymore, right? I mean, there's very few places, certainly east of the Mississippi, where you could even do that. So I think returning to that is a very important part of what we'll be doing, is again, providing that in-person experience. I imagine on the educational front, because of things that we're doing and learning now, we're going to also be developing programs for schools where teachers can engage with our telescopes and collecting data and then using that in their classrooms. So, those are some things that I think are in the short term. We never know where technology takes us, though. I expect a call from Kevin at Skywatcher in 2 years to say, hey, you won't believe this new camera that's being developed, and it'll take us in a whole new direction. So
yeah, I know you guys have some of our scopes piggybacked on your big old things up there, so
we do, and they are quite popular, and actually it's I should mention, back to the outreach, they're important because when we point a 32-inch telescope, say at the Triford Nebula, like you're seeing behind me, that's pretty much what's in the field of view of an eyepiece. But then when they can look through the 6-inch Skywatcher refractor that's on the same target, they understand the context. And then we can point up in the sky exactly where that is. And so those different fields of view, right, also help them create an understanding of the night sky. They begin to get some sense of what 180 degrees is across the sky, and how the motion of the sky works, and things like that. So it's not just beautiful looking through the refractor, but those different views do help provide people a more complete understanding of what they're looking at.
Mm-hmm. No, and that's good to have the different optic types too, to understand field of view and what fits and why there's different telescopes, because everybody's like, what's the best telescope, and you guys having the mix of that.
Right. The answer is always the one you use, right? And we say that because people will ask us, right? Well, if I wanted to buy a telescope, and then we do tell them that. But the great thing about having those Skywatchers as well is they see these amazing views and they realize, I could carry that out of my backyard, right? It doesn't have to be mounted on a 32-inch telescope. It could be mounted on a nice small mount. And so having the small telescopes also opens up the hobby for people that are interested in being amateur astronomers, or that already have started along that path, and that's why they're there. They're ready to move on from their binoculars to a telescope. And it's I love looking through the 32-inch, through the 24-inch, but at the end of the day, truthfully, I'm happier sitting in the middle of the desert behind my own 5-inch telescope or my own 12-inch telescope, right? Because it's mine. And I'm running it, and it's not connected to a computer, and it's just there's something very basic about that, right? And being able to explore the night sky on my own, and and take things in a direction that I want to take them, and I think that it's anyway.
No, so I know you and I could go on forever about. We've had long conversations in the desert that have sprawled late into the night about stuff like this. So now we've got 10 minutes left. If you guys have any questions right now, now's the time to throw them into the chat. We'll still continue talking here, but if there's a question that pops up, go ahead and throw that in the chat, and I can ask Alan for you guys. If you guys want to know more about the Sky Center, I'm going to put the link in the description below if it's not already there. So if you're watching this now, it'll be there shortly. If you're watching this in the future on this recorded, the link will be down in the description below in the video. That'll just link right to the Sky Center website, so you can go learn about programs and availability and pricing and all that fun stuff. But Alan, if they're in Tucson, you guys actually have like a headquarter facility not far from the mountain.
We do. And before I tell you about that, I'm laughing at myself because I see your telescopes all the time on ours, and I'm just noticing the tagline under your logo, "Be amazed." That's great. That's I wish we'd thought of that. That's a perfect astronomy
copyrighted.
Yeah. But anyway, Yeah, so we have a office. Our headquarters are actually right at the base of Mount Lemmon. If you're in the area, it's 8892 East Tankaverde Road. You have to pass it if you're going up Mount Lemmon. And so not only are our offices there, but we have a astronomy and science themed gift shop. So a lot of the guests from our programs can stop on the way up and buy warm things, blankets and sweatshirts and stuff like that. Or after their program, lots of astrophotography and children's books, all kinds of stuff. Our goal with it really, besides the bottom line, is to keep people engaged and excited and stop by. We try to keep refreshing the different products that we carry. And when we are not in pandemic times, we also do star parties there so that people in town or in the neighborhoods can come by and in the parking lot and look at stuff. And it's nice because it gives us a presence in the community, right? Not everybody can come up to the mountain and do a 5-hour program at high altitude. So it's nice. And we were just getting started before COVID hit. We've been open less than 6 months. So we've been recently talking about a new grand opening when we can. So
let me know. I'd love to be down there. That
yeah, if you go to the website, then you'll see a link on the website. We have an online store also. So not to be too pitchy about stuff, but anything that people purchase stays right with us. There's 100% of it stays at the Sky Center to fund outreach and education and keep the eyepieces clean. That's what I like to say.
Go. And then if they wanted to learn, so last week's episode was about like holiday gift ideas, and for the advanced imager, actually one of my ideas was getting time on remote telescopes, and your facility was one of them. All that information on the website for how to obtain that remotely.
Yeah, it's all on the website for sure.
And are both the 32 and the 24 available for that, or is it just the 32?
So the 32 is primarily the one that's available. We do use the 24 remotely, but as of right now, we haven't used it. We haven't turned it over for astrophotography. Mm-hmm. And the reason is twofold. One is that our camera and filters, everything's kind of set up on the 32. But the other reason is that we do have some science projects that take advantage of unsubscribed time on that telescope. And one of them in particular, which is looking at transiting exoplanets, we can move them to the 24-inch with their stuff pretty easily if we have astrophotographers using the 32-inch. So it's just kind of, it's like dominoes, right? Everything falls in order. So,
yeah, exactly.
Yeah, but the 32-inch, right, is really, it's a special scope for astrophotography. So I'm not an astrophotographer, but if I was going to do it, I'd want the 32-inch. I'd want that 0.8 meter aperture.
There's plenty of images up there on your website that show the capability of that site. And for those who haven't been there, it's what, 9,100 feet?
9,170.
Yeah, you're up there quite a bit. Like, if you're used to like Tucson, Arizona weather, it is completely different. I've been out there in the spring, and it's nice and warm, and we've done some big events at the University of Arizona where it's rather toasty during the day, but at night we've gone up to the mountain and it's cold. Yeah. So
and as far as seeing, what we call the seeing conditions, right, the stability of the sky, it's a very, very good site for astronomy. So Kevin, you know this, right? Astronomers measure those seeing conditions. They quantify them in a measurement of arc seconds, right? So there's 360 degrees around the sky, right? 180 from horizon to horizon. Each degree is 60 arc minutes. Each arc minute is 60 arc seconds. So there's 3,600 arc seconds in a single degree. And so typically on Mount Lemmon, or no, I shouldn't say typically, but we have many, many, many nights up there where the seeing conditions are measured at less than 1 arc second.
Which is,
meaning,
yeah.
Right? Meaning we could separate objects that were, that distance apart. And, and I don't know what the average is, but it's, probably just over 1 arc second throughout the year. It's maybe 1.2 arc seconds. It is a very high quality astronomical site.
I know that comes up with people who do astrophotography a lot is, oh, I need to get my guiding under 1 arcsecond. Well, half the time you're imaging in your backyard and the resolution of your system already is like 1.5 at best. So
Right.
a lot of times it won't resolve. But as you can see from the image behind Alan, that's on a 32-inch telescope. So you need to have such good seeing to support an instrument of that caliber. So it's a sight like that.
Yeah, on the 32-inch in particular for remote astrophotography, is that it's a friction drive system, right? There aren't gears, so there's no periodic error in the system in the same way. We can routinely do 300-second unguided exposures up there.
And that's on a 32-inch like f7.8. You're up there in focal length.
Yes, for sure. For sure.
Yeah,
it's definitely, it's a dream job for an amateur astronomer, and I feel really lucky because I know that, like a good friend who I respect advised me before I took the job to be careful that sometimes you make a hobby your job and then you burn out on the hobby. And, for me, if anything, it's probably kept me more excited, more involved because I can't not see some of the exciting things that are happening all the time.
Yeah. Real quick question. What CCD camera is currently in use on the 32-inch Shulman telescope?
Well, that's a great question. And I'm just going to get my facts right now because you heard my disclaimer. I'm not an astrophotographer, right? So it is, I'm actually going to go to our website to get the exact thing. It's an SBIG, Santa Barbara Instruments Group, but I just want to find the exact model for you. Of course, the astrophotographers are going, well, there's only 3 good cameras to put on the telescope. Observatory, it is a SBIG STX camera.
So I think it's a 16803 sensor.
Yeah,
you need to have big pixels on that big of a telescope.
Yeah. So we are actually looking over the next year to get another camera. It'll be a CMOS camera because it does seem that the future of cameras is going away. Those 16803s are no longer being made. And so we want to at least get a little bit ahead of the curve so we get some understanding of how these new cameras work and can kind of commission it so that at the point when, our camera dies, and they all die at some point, right, that we're ready to roll. Or, we may start seeing astrophotographers who want the data from the newer cameras. So.
Mm-hmm. Next question, is the RA dome still up on the mountain?
The Ray dome? Yes, not the one that was in use with the instrument, but the tower is still there. And there's a geodesic dome that's over it to protect the pier. So that building will stay. We have dreams and visions of putting a telescope on the top of that pier. It would support a pretty good sized telescope, but we would need to do it in a way that also is synergistic with the natural environment and the goals and visions of the Forest Service. We don't want to stick a 4-meter telescope up there that's visible from Flagstaff. So.
Let's see. Next question. Do you take 30-second snapshots through the 32-inch when you show the public?
Sometimes. It just depends what we're doing. It's primarily a visual program, but often at the end of the program or on a really bright object, we will take a DSLR camera and put it in there and take a picture because it is also a learning opportunity for guests to understand something about the difference between the camera and their eye. We will more often do it, any guest that brings a DSLR, we'll put it in the Skywatcher, right? Because that way we can continue with the visual observing, which is what most people are there for. But also it gives guests an opportunity to get some cool shots through the refractor.
Yeah. Yeah, if you guys go up there, they have an Esprit 150 piggybacked. Yes, I said piggybacked on the 32-inch. Actually works out quite well, but to see
it... to be 100 on the 24-inch.
Okay, and the Esprit 100's going on the 24. So there's 2 Esprits up on the mountaintop, or will be up on the mountaintop. But
And we even have T-rings for various cameras, because a lot of people that come up just with cameras are not astrophotographers, but it's a really great way to help them appreciate, a small telescope and an off-the-shelf camera. You can start doing some really neat stuff from your backyard.
Well, very cool. Well, that pretty much wraps it up. If you guys have any questions for Alan or the Mount Lemmon Sky Center, you can either shoot them over to me and I can send them over to Alan, or you can just contact the Sky Center through their website. Again, if it's not in the description below, I'll add that later today for the description, so it'll link you to their website. Again, there is no webcast next week because it is Thanksgiving, so we'll jump into the week after that. If you have any further questions that I didn't get to cover, you can email us at support@skywatcherusa.com and just title it "What's Up," and then we'll take a look at that. But thank you very much for Alan for taking the time out of your schedule. I know you're pretty busy with a lot of this stuff, and thanks for everybody who's been watching.
Yeah, thanks for having me. This is important, and I'm really appreciative that Skywatcher is so invested in astronomical outreach.
We try. We want everybody to have a good time. Real quick, Cameron, they use teleview eyepieces on the telescopes up there. That I can't answer because
not entirely, but for the most part. We have a pretty nice set of Explore Scientific also.
That's right. Both of them are great. So just so you answer your question there. All right, guys. Well, that's it for this week. Thanks, Alan. If you guys need anything else, like I said, just email us at support@skywatcherusa.com. Title it "What's Up." If you like it, go ahead and subscribe to our channel. And we'll see you guys in 2 weeks at this point. No webcast next week. So it'll be the following Friday, the first Friday of December. We're talking about what's up in the December night skies. So thank you very much. Have a good weekend, guys. Stay safe and go look at the planets and the moon because they're up right now. So thank you very much and have a good weekend.
Thanks, Kevin.